Okay, so on Friday, I know it seems like a bit of time ago, but we basically ended class with four very common valid arguments. Okay? And I think I mentioned this before, but you do not necessarily have to memorize these by name, but if you recognize the arguments, you can just say, yes, this is a valid argument, or no, it's not. And some of these, if you come up with a silly example, will help you remember, is this a valid argument or not? Okay? Here are some things that are very common, very commonly mistaken for valid arguments. The fallacy of the converse. So that looks something like this. If P then Q, Q, therefore P. Okay? This is not valid because the converse doesn't, well, first of all, we know from before the converse of a statement is not necessarily true. That's one reason this is not valid. Another reason, just think of a really basic example. Like, let's say P is, if there's a blizzard, school is canceled. Okay? So here's the argument. If there's a blizzard, school is canceled. School is canceled today. Therefore, there was a blizzard. Think about that for a second. Does that necessarily mean, just because school was canceled, that there was a blizzard? There could be other reasons that school is canceled, right? I don't know if any of you were here, but there was like a power outage one day. Okay, was that maybe your freshman year? Power went out in the morning. They said, you know what, go home. School's canceled. No blizzard, we just didn't have power. Okay, so the converse, just because the conclusion happened, it does not mean that the hypothesis happened. Okay? Inverse, let's take a look at that. If P then Q, not P, therefore not Q. And it's pretty much the same story. Think of that same example. If there is a blizzard, then school is canceled. There is no blizzard. Therefore, school is not canceled. We've already talked about that. It could be canceled. There could be other reasons, right? So this is not a valid argument. Okay? Here's another one. Misuse of disjunctive reasoning. Disjunctive is or. So we start with an or statement, P or Q. Then we have P, therefore not Q. This is an invalid argument, and so is the other version of this, where we say P or Q, and then Q, therefore not P. Here's a, again, silly example that hopefully will convince you. Let's say that for this class, you can use pencils or you can use pens. So P for pencils, sorry, Q for pens. What does this say? You can use pencils. Does that mean then that you are not allowed to use pen? No, you can use pens or pencils. You can use pens, you can use pencils, you can use both, right? This is the same thing. You can use pens or you can use, you can use pencils or you can use pens. You're using pencils, therefore, I said that backwards. You're using pens, therefore you're not able to use pencils. Well, that doesn't make sense either. It's the same thing, okay? An or statement is not an exclusive, like it's got to be both, or it's got to be one or not the other. It can be both and it's still true, okay? Transitive arguments. Misuse looks something like this. If P then Q, if Q then R, therefore If R, then P. Again, think of a silly example. Let's see if you guys can follow me here. Let's say P is there's a blizzard, Q is school's canceled, and let's say R is you get to sleep in. Okay? Listen to the argument. If there's a blizzard, then school is canceled. If school is canceled, then you get to sleep in. Therefore, if you sleep in, then there was a blizzard. Think about that. Is that the only way you get to sleep in? What else could happen?
You just do it.
Yeah, you just do it because you want to sleep in. I was going to look for something like maybe it's a weekend, not the ditching type, but okay, so this is invalid as well. What should this be so that it makes sense though? Rather than if R then P, it should be if P then R. So it should be if P then R. This would now be valid. And now it would make sense. If there's a blizzard, then school is canceled. If school is canceled, then you get to sleep in. While there was a blizzard, then you get to sleep in. That sounds a lot more like a solid argument than the other way around. Not valid. All these are not valid. All these are not valid. Okay? Any questions on that? You do not have to know, like I think on my math lab it might ask you like which invalid argument it is or what the common mistake is. On the exam, you just have to recognize, yes, this is valid or no, this is not. So let's do one example of what that might look like and then we're done with notes. I know there's a few over here, but we're only going to do one. Okay? Just take a minute or two and read through example A. Okay. So I've gone ahead and just taken the two main parts of this argument and defined each letter. Defendant's DNA is found at the crime scene. That'll be D. He stands trial. That'll be S. The rest of this is just variations of these two sentences. So, symbolically, okay, if we start with the first sentence, right here, if the defendant's DNA is found at the crime scene, then we can have him stand trial. This first sentence, how would I translate that? D, then S, and now let's use a different color. Second sentence, he is standing trial. How would that translate? S. Therefore, that's where I go like that. We found evidence of the DNA at the crime scene. So that's just D. Okay? I'm going to do all the symbolic stuff first, and then we're going to talk our way through it, and then do a truth table. Okay? So when you translate this in one line, so instead of having premise 1, premise 2, therefore, conclusion, do you guys remember what we did with these premises on Friday? Because this, if you write it in one argument, in one line to make a truth table, it kind of gets pretty large. Do you remember how we linked everything together? With ands. Every premise gets linked together with an and. So if I'm writing this, we go if D then S and S. And if I had more premises, I'd put parentheses, do an and put in the third one. Okay? This is the first half. What comes next? The conclusion, D. Remember that any argument is always premise 1 and premise 2 and so on and so forth. Then the therefore goes at the end. Okay? So this is what we have. This is it written out line by line. This is in one line. Okay. Let's see if we can figure it out without a truth table. Okay? So just listen to the argument. The defendant's DNA was found at the scene. Or I'm sorry, let me backtrack. If the defendant's DNA is found at the scene, then the defendant can stand trial. The defendant's standing trial. Therefore, DNA must have been found at the scene. Who thinks, yes, that is a valid argument? I like how you were, and then you looked around, you're like, oh. 1, 2, 3, 4, 5, 6. Who thinks this is not a valid argument? 1, 2, 3. A slow 4. Anyone else? A 5. So 6 to 5, and then who has no idea? You can be honest. Oh, you changed it now?
No, I answered 2 times.
You answered 2 times. Okay. So listen carefully, because when you're doing arguments, remember your goal is to if you want to build a solid argument, you should not have any loopholes whatsoever. Okay? Think about what this is saying. If the DNA is found at the scene, then he stands trial. He is standing trial. Therefore, DNA must have been found at the scene. So here's what you do to kind of think, is this valid? Is the only way that a defendant is put on trial if their DNA is at the scene?
No.
What other reasons could someone be standing trial?
There's a witness.
There's a witness. That's a good one.
There's video footage.
Sure, video footage. There's some other kind of evidence, right? And that's enough to say, we have you. You're guilty. We're going to put you on trial. Does that make sense? Yeah. DNA is not the only way that someone gets put on trial. Does that make sense? Yeah. This is invalid. This is a form. This is the fallacy of the converse. Okay? Which is invalid. Now, here's what it comes down to. Only 4 or 5 of you said, that's not valid. Hopefully that wasn't a guess. If that was you, then you're probably one of the few that can look at a problem like this and just say, not valid, and move on and get all your 6 points. If the rest of you looked at this and thought, oh yeah, that's valid, or had no idea, you should probably do what? Sure. And what else should you do? Study, ask questions. What else? What if this is practice? What else? How else do we determine if something's valid or invalid?
Ask yourself questions.
Truth table. There it is.
There you go.
Okay. A truth table, as long as you set it up correctly, will always tell us the way. Okay? So rather than do 2 more examples, what I'm going to do is just redo this problem, but set up a truth table, and we'll see why it's not valid. Okay? So, we have D, we have S. Here's what I'm trying to, right here is what I'm trying to do a table for. So what else should I have? What other columns? D then S, sure. D then S and S. So in other words, the whole thing. Oh, wait. No, yeah, we're good. Okay? Fill it out. Take a minute. Fill that out. It doesn't take too long. I know it's tedious. I know it might take you another minute instead of just looking at it and figuring it out. But it might be worth the time. What was the question? That's a good question, I think. So that's a great question. For an argument to be invalid, all you need is one of them to be false. If they're all false, definitely invalid. Even if it's just one thing that's false, though, that's invalid. For an argument to be valid, though, every single scenario has to be true. Okay? So, if you filled it out, you should be done by now if you know how to do these. What happened? Where's the issue? Why is this not a valid argument? One of them ends up being false, right? Let's see. When is an if-then false?
True, false.
True, false. So here's false, true everywhere else. Here's an and statement. We're looking at these two columns right here. When is an and true? Both true. So it should be true, false, true, false. And now we're linking this column with a then, if then, to D. So we're going from here to here. When is an if then false? So this is true. False then true is true. Here's the issue right here. Do you guys see it? True then false is false. So even though it looks pretty convincing, there's this one issue right here. Okay, so if you need to make a truth table, even though I don't give you a truth table to fill out, you can make one real quick and figure it out that way. Does that make sense? Okay, that is the end for Unit 1, which is Chapter 3.